Hi guys, today we're going to learn about the area under the curve or Riemann sums. So we have here a function y equals x squared plus 1, which I'm going to call it f of x. Okay, so you need to estimate the area bounded by the graph of the curve and the x-axis from 0, x equals 0 to x equals 2 by using A, the left Riemann sum with n equals 4 subintervals. Okay, so the first thing that I'm going to realize is that's left. I want 4 equal subintervals from the interval 0, 2. Okay, so first let's draw the picture of what we have in this situation. Okay, so you have your x here, and for the sake of this problem I'm going to do my my numbers here very big. So you have this is 1 and this is 2. So the interval that we're basically looking at is from 0 to 2. And they are telling you that you want 4 intervals. Okay, so what I do is I take this one, that the length is 2, I divide it by 4, and I know that the length, okay, the length of each subinterval is going to be 1/2. Okay, so I know that over here I'm going to have an interval and another one here. So you have from 0 to 1/2, 1/2 to 1, 1, 2, 3 halves or 1.5, and then 2. Okay, so this is your x. Now what's going to be the deal with the y? Well, the deal with the y, you already know that if I plug 0 here, I'm going to have that it's 1. So for the sake of this problem, let me just create this my graph. This is going to be 1, 2, 3, 4, and 5 is going to be over here. Okay, so this is 5 and this is 1. Okay, so let's look at more colors here so you can see the points. Okay, so the first point that I have at 0, I have that it's going to be here. Then at 1, I know that if I plug 1 there, I'm going to have that this is going to be 2, so you have this dot over here. And then at 2, you know that it's going to be 2 squared is 4 plus 1, that's 5. So you have that it's going to be over here. Okay, so connect your points here. So what do you have here? Something that looks like a parabola, which you know that that's pretty much the equation that we have here. Okay, so now what are you going to do here? Okay, what you're going to do here is you want the left Riemann sum with 4 subintervals. So the first rectangle that you are going to have in this situation, it's going to be from 0 to 1/2. The second one 1/2 to 1, 1 to 3 halves, and then 3 halves to 2. But you're going to tell me how tall is that rectangle that we have. Well, you need to realize that we need to find the left endpoints. And the left endpoints from this situation are going to be from the first interval, you know that it's going to be 0. From this interval is going to be 1/2. Then if you're looking at this one, is going to be 1. And the last interval that we have here, it's 3 halves. Okay? So those are going to be your left endpoints. So pretty much here you need to also realize that we have this point over here and this one here. Okay? Assuming that I'm correct with my computations there. Okay, so what's the next thing that we have? If you realize, if I have the left endpoints, I know that at 0 I'm going to take that height. So I'm going to create my rectangle as follows here. Okay, so this is going to be your first rectangle. Your second rectangle is going to be based on the height of the left side. So this is going to be your second rectangle. The third rectangle, as you can see, I'm basing this on the height of the left endpoint, okay, which in this case it was 1. That's going to be your third one. And your fourth one is going to be height, this one, okay. So that's going to be your fourth rectangle, okay. So as you can see, it's pretty simple if you remember from geometry or below, that the area of a rectangle is base times height. So you know that this base is 1/2, and the height, what's going to be the height? You're going to tell me, well, I'm not sure what's the height. If I call this f of x, do you agree that it's going to be f of 0? Why 0? Because that's my left endpoint on this equation, okay, meaning the height. This is the height. So plus 1/2 times f of 1/2 plus 1/2 times f of 1 plus 1/2 times of f of 3/2, okay? So pretty much we're doing base times height 4 times because we have 4 rectangles. Okay, now you need to evaluate what is f of 0. You know that f of 0 is 1, okay, because you plug the 0 here, plus 1, that's 1. Okay, so then you have 1/2, f of 1/2. You have that f of 1/2, it's going to be 5/4 plus 1/2 times f of 1. You know that f of 1 is going to be 2 plus 1/2 times f of 3/2, which is going to be 9/4 plus 1. That's 13/4. Okay, so when we do these computations, when we add them together, you have that this is 15/4, and that's going to be your left Riemann, the area under the curve with left Riemann sum. Okay, so that's going to be your answer. Okay, let's move on to the right Riemann sum. If we have a similar situation, let me draw exactly the same thing that we had. Okay, so we have, what do you have here? Well, we have 1, 2, and then kind of like there. Okay, so we have 1/2, 1, 3/2, 2, and then I'm going to do exactly the same here. 1, 2, 3, 4, 5. Okay, so we have 5. This is your 1. We have the same situation here. Let me get my marker here. So we have 1, this was 2, and this was 5. Okay, so as you can see, I'm doing exactly the same thing as I did on the previous question. The only thing here, I'm going to do a different set of rectangles. Okay, so what do you have here? The length, okay, of each subinterval. Okay, the right Riemann sum with n equals 4 subintervals, same big intervals, so it's from 0 to 2. Okay, so you have your subintervals here, 1, 2, 3, 4. Okay, what are you going to do? Again, the length of each subinterval is 1/2. Okay, now the thing that changes is that you know that the right endpoints, what's the deal here? The right endpoints are not going to be the same, because instead of looking at the beginning, I'm going to look at the ends of each rectangle. Okay, so are going to be 1/2, 1, 3/2, and last but not least 2. Okay, so it's pretty cool to see that now we're paying attention to this side. Okay, so what's going to be the difference? Here you have the right area, so let's look at our rectangles here. Let me draw them again. Now here, what I'm going to look, again, if I draw the points of this one and then this one, okay, what are you going to have? Okay, so here you have that the height is going to be the height of the right side. Okay, so this is going to be the right, as you can see, this is the right one. Okay, and last but not least, this is going to be the right one. Okay, so let me just draw my rectangles so they look nice. Okay, so you can see here, this is my first rectangle, this is the second one, this is the third one, and this is the fourth rectangle. Okay, so as you can see, the first rectangle, you know that the base is 1/2, but the height of this one is going to be f of 1/2 plus 1/2 times f of 1. Okay, and then you have 1/2, okay, times f of 3/2 plus 1/2 times f of 2. Okay, you see it? So as you can see, if we compare these two drawings, I'm overestimating here and I'm underestimating over here. So that's the big deal. So naturally, this is going to be a bigger number. Okay, so following the same trend, you have that this is 1/2, and you know that f of 1/2, we said that it was 5/4 plus 1/2 times it was 2 plus 1/2 times this was 13/4, and last but not least we have 1/2 times, and this is going to be a 5. Okay. Similarly, we add them together, obviously multiply, then you add, and you have that it's 23/4. Obviously, if you compare these two numbers, you can see that this is an overestimation, this is an underestimation in this situation because my function is increasing. Okay, so you know that the actual value of the area under the curve is in between these two. Okay, in case that you were wondering. But that's not it. We have another type of Riemann sum, which we also love, which is going to be the midpoint Riemann sum. The midpoint Riemann sum in this situation, as the name tells you, we're going to compute the midpoint, and in this case we want the sum with 4 equal subintervals. So again, since we want equal subintervals and we want 4, you know that the length of each subinterval is going to be 1/2 again. So nothing too strange, pretty much the same as before. The thing that it's going to change is the following. So the height is going to be different. Why? Let's look at the drawing again. Okay, so we have, it was kind of like this. I'm trying to use the same scale. So 1, 2, you have that this is x. Then we had 1, 2, 3, 4, 5. Okay, so this is 5. This is 1. And then we had, what do we have? We had this point, then this was 2, this was 5, okay, and you have here your parabola. Okay, so we have our parabola here. Okay, so obviously you have the 1/2 that we want and the 3/2 that we want over there, and let me also draw those dots so you can see them. Okay, so we have that, right? So you're going to look at your interval here and you're going to tell me, well, what's the midpoint? You have 4 intervals. First, look at the interval 0 and 1/2. What's the midpoint of 0, 1/2? Okay, from geometry, you know that it's going to be 0 plus 1/2 divided by 2, which is 1/4. Okay, so the midpoint of the first rectangle is going to be 1/4. Okay, so whatever is this one, that's going to be your height, okay, of the first rectangle. The second rectangle that we have, let's call it C1, okay, it's going to be what? It's going to be 1/2 plus 1 divided by 2. From geometry, this is the midpoint formula. You know that this is going to be what? 3/4. Okay, so you should have something in between here, 3/4. Okay, this is your 1/4. Okay, so that output is going to be the height that you want. You see it? Okay, then you have that the third midpoint that we have over here is going to be 1 plus 3/2 divided by 2, which we know that it's going to be 5/4. And similarly, you have that the last one is going to be 3/2 plus 2 divided by 2, which you know that it's going to be 7/4. Okay, so here's your 5/4 and your 7/4 should be here. Okay, so those are going to be the heights that we have. Let's do kind of like guesstimate here what we have here. Okay, so that one, and then we have a situation like this. Okay, so that's going to be the height from here to here. This is going to be the height from here to here, and then this one, oof, I did it quite ugly there, so I apologize for that. Okay, so you have that rectangle, that is the second one, the third one goes here, and the fourth one goes there. Look at those beautiful rectangles. So 1, 2, 3, 4. Okay, so this one is overestimating in some pieces but underestimating in other pieces. So that's another estimation that we have here. Okay, so the area of the midpoint, how can we compute that one? So the base is going to be 1/2, as you can see. But what's the height? The height is not 1/4. It's the output when we plug the 1/4 in my function. So it's going to be f of 1/4 plus 1/2, the second rectangle, times f of 3/4 plus 1/2 times f of 5/4 plus 1/2 times f of 7/4. Okay? So as you can see, I'm going to plug this one in my equation. Let me show you what I'm going to plug so you know what I'm doing. Square plus 1. Okay, that's what I'm plugging. Plus 1/2, and then you're going to have 3/4 square plus 1. Close it. Plus 1/2 times 5/4 square plus 1. Close it. Plus 1/2 times 7/4 square plus 1, and close it. Okay, so you could leave it like that technically if you don't have a calculator, but since we are here, I'm going to tell you that this is 37/8. Okay, so you can see the difference between these types of Riemann sums. For this problem, what we have is that water is flowing into a tank over a 12-hour period. The rate at which water is flowing into the tank at various times is measured, and the results are given in the table below, where R of t is measured in gallons per hour and t is measured in hours. The tank contains 150 gallons of water when t equals 0. Okay, so they are asking you to estimate the number of gallons of water in the tank at the end of the 12 hours by using left, Riemann sum, and 3 subintervals and values from the table. You need to show the computations that lead to your answer. So what's the deal here? Here, what you have is that these intervals, I see them and they are not the same length. This one is 5, this one is 8, and this one is 4. Do you see them? Okay, so this one is 5, this one is 3, and this one is 4. Okay? So you are like, oh my goodness, what are we going to do? No worries, okay? So you are like, okay, I'm in the business of left endpoints, okay? So what are your left endpoints in this equation? So you know that it's going to be 0, 5, and 8, okay? So I'm looking at the beginning of my rectangles, okay? Now, the length, okay, the length of each rectangle is going to be different, okay? The length of this one is going to be 5, the first rectangle. The second rectangle is going to be 3, and the third rectangle is going to be 4, okay? So when I compute the area of the left Riemann sum, you know that this is going to be equal to, the base is going to be 5, and the height is going to be the output at 0, which is 8, okay? Plus, you know that the base is going to be 3, and the height is going to be your output at 5, which is 8.8, plus 4 times 9.3, okay? So I compute this, and this is 103.6, okay? But that's not it. I know that the tank at the beginning contains 150 gallons. So I know that what I have in the tank is 150 plus 103.6. Therefore, what do you have? The left, okay, estimation, okay, of gallons of water in the tank at the end of 12 hours. The 12 hours is 200 and what was it? 53.6 gallons. Okay, so that's what we have for this problem. This should be your answer. Where this 150 comes from? read the problem here. The tank at time 0, it has already 150. So 150 plus my estimation from the table. Okay? Similarly, for part B, what we want is estimate the number of gallons of water in the tank at the end of the 12 hours by using the right Riemann sum, and then we have 3 sub-intervals and the values from the table. Again, the difference between the right and the left one is just that you know the right endpoints. Okay, so as you know, the right endpoints, instead of being 0, 5, and 8, are going to be 5, 8, and 12. Now, the length of my intervals, of my sub-intervals, is going to be 5, 3, 4, respectively. Okay, so that one is not going to change. So the thing that changes is the right endpoints. Moving on, the same idea, you have that the output at 5 is going to be, or well, let's start with 5, that's the base, and the height is going to be, you plug 5 inside your table, and the table gives you 8.8. So that's going to be your height. Similarly, we have that your length is going to be, of that sub-interval is 3, and the output is going to be 9.3. Plus, then we have 4, okay, times 9.2, and then we combine this, and you have that this is 108.7. Similarly, we realize that this is not alone. We have the 150 from time 0, so therefore you have to add this 108.7 with the 150. Therefore, the right, okay, the right estimation of gallons of water in the tank, okay, at the end of 12 hours is 258.7 gallons. And that's pretty much it. Okay, I hope that you find this video helpful. Bye!